Hello. At least I think you've seen online, if you are in an IT, that some people use this OpenAI playground or chat. And why, how they use it, they say, give to me a function, and this function is code. And they look overly impressed. And just to be very clear, it is very cutting edge and it's impressive as a feature. I would say it is also dangerous for some things, which I will discuss them later. But the main part which I would want to alert people is that if you are not quite specific, you may get a different code. Also, what I noticed is that even using the same account, so here it's really the same address, email address, I noticed that the code asking basically the same question, maybe with a synonym, it will give to me different code. So this code versus this code. So this was just in a different type of the day, the same account. Okay, this function versus this function. And I noticed that if you add the keyword like fast, it will not change it, the code. But what I was also more curious too is that I tried to say, okay, so maybe I will try to use a generator just to see if it will try to, maybe we can check just the last number. And why I'm saying this is that some people think maybe it will be nicer, or maybe they will even need the last numbers. And obviously, the benchmarks, these benchmarks are not up to date. So we'll check the benchmarks. So obviously when you look into the code, you go as the code is written. You have here first function. Here you have the second one where you increment by 2 versus incrementing by 1. Probably this one it will be faster. But you'll not know if you'll not measure them. But what I found it really stunning is what will happen if you'll take that generate primes and you'll put it in a loop or something like that. At least on my machine it was killing the performance, so I use these primes in the original code, but I will recycle the collection. So I put it as a static field and I clear it every time. Maybe it's not the best practice, but it's really a huge improvement as speed is concerned. So even when you go like this, you'll see the performance is horrendous. And it's not because I'm using the last here. The last is specialized. So the first thing that it should be done is that when you check for your candidates and you have an already existing list of primes, if your primes are exceeding your candidate I here, you should not look if it's divisible anymore. You can say it's prime, and if it's prime, you add it. So this improves, you'll see quite a lot the code. Later you may think maybe you do too much iteration. This looks like a hot iteration. Maybe you remove the bounce check, you'll make an array, and you have a position inside, and you increment the position by 1. So it's the code as before. So you keep this optimization, but you iterate over an array. And let's say if it speeds up, and then you can do even more. So you keep the main loop, but if you find a prime number, you can check, is that prime number a divisor? This should speed it up also a lot. And also if the candidate, this is a new prime number, multiplied is bigger than your prime numbers, there is no point to check for any other number. Okay, so this is another optimization, and I forgot here what it was done more. there was something else more here. The alternate. Yes. So here, in fact, I will start the prime numbers from number 3, because here all the candidates numbers, I will test them ahead of time if they are divisible by 2. And I'll start just from 3, 5, so I'll skip number 2 as a divisor. Would it improve it more? Because it's a useless test. And let's test it. And then we will discuss. So I click run. Okay, so we're back. So the test took a few minutes, around 5, 4. And let's see the results. So first of all, let's start with the first function. So the first function was giving around 1.5 microseconds results, and this is in a quite fast laptop processor, but not the fastest by far. Similarly, the test primes 2, because it goes 2 by 2, it is in less than 1 microseconds. But here is the stunner. So if you were using the generator with no optimization, you will really talk about 6 seconds, not milliseconds, not microseconds, 6 seconds. If you go to square root, you talk from 6 seconds to 23 milliseconds. If you do this iterating over the arrays, you can see there is an impact, but not much. So it's from 23 milliseconds to 22. It's measurable, but still not good enough. But if you use also the powers of 2, when you just get a new power number, you go again into 3 microseconds, and if you skip the number 2, you reach under 3 microseconds. So the moral of the story is that even with your intuition that you may use an array can look right, you don't know really what you get out of the code. And obviously you can get very good code, and I want to say that this test prime 2, it is very good. I know personally why it's faster than even a very optimized array based candidates, and it's based how CPU caches work and how the processor can predict data, and here basically works only in cache versus here it accesses memory. But still, between this algorithm and this algorithm are just refinements, and the refinements made this code really 6 orders of magnitude faster, and at least 2 orders of magnitude off with a very simple optimization. So that's all. Be aware, and don't throw your code from OpenAI. And the risk where I see it the highest is not the quality of the code. It may be very fast. It may be whatever. First of all, I see it in education. So students, instead of making their homework and understanding, they can get the code from somewhere like a cheat code. The other part, what if it has a bug? And I'm not saying that test prime gen r opt alt is the optimal way either. But this code, at least I understand it because I wrote it. And I forgot to say, this test prime gen had this allocation issues. So you see it has 6 seconds, but it had an outlier of around 85 seconds. And I personally know why. It's a garbage collection probably it was issue, or maybe not. But I even avoid allocation, so still it can stay 85 seconds or some seconds. But anyway, seconds to do nonsense. And why? That's the realistic questioning, when it shouldn't check probably ever. Um, and you'll have to inspect it. You have to spend time with some code that someone introduced, and you have no clue why it generates memory. What should you do with it? Is it how you iterate, how you allocate? And this can kill any medium to big software. So don't go with that work, excluding that this is just a toy project, like just to benchmark to see what's the best or the worst code. Thank you, and if you like this kind of subjects, please comment underneath. Bye bye.